So today we're going to look at the final for the pre-algebra 8th grade, which basically covers everything we've done the entire year with an emphasis on the stuff from the most recent quarter, but there are stuffs from other quarters in here too. So let's dive right in. The first three things we have are formula problems, which are the volumes of three shapes: cylinder, cone, and sphere. And the reason these are often bundled together is because they have very similar formulas to them. So a cylinder formula, which is something you have to remember, is volume equals pi r squared h. Just something you have to memorize. Pi r squared h. Pi r squared being the circle area, and then h being the height of the cylinder. So in this case, it's just basic plug and chug. V equals pi times 2 squared times 5. Do those arithmetic here, you get 62.8 centimeters cubed. Again, you have to plug that into your calculator. Boom, knock it out. Because you don't want to do this pi square stuff by hand. So a cone is just like a cylinder, except it's pi r squared h divided by 3. So it has a divide by 3 on it because a cone is 1/3 that of a cylinder. But same thing, plug and chug. So pi times 3 squared times 11 all divided by 3. And if you plug that in, you get about 103.62 centimeters cubed. Once again, it's very formulaic. You either know the formula or you don't. The sphere is the oddest of the bunch. It also has a formula, but it does not have an r squared because a sphere does not have a height. There is no h involved in a sphere because a sphere is the same in all directions. There is no reason to have an h there. So the sphere's formula is this: 4 pi r cubed divided by 3. Or some people call it 4/3 pi r cubed. So it's kind of like 4 cones, but instead of having a height, you just have 3 radii. So there's no h, it's just r cubed rather than r squared. Now, in this case, that 4, that's the diameter. That goes all the way across. So my radius is actually going to be 4 divided by 2, which is actually going to be 2. So this sphere has a radius of 2, not 4. So it'd be 4 pi 2 cubed over 3, which would give you about 3.943 repeating meters cubed in terms of volume there. Okay. So again, the first three there's nothing really special about them. It's just very formulaic. You either know the formula for a cylinder, cone, and a sphere, or you don't. And then you go from there. The next two are also kind of formulaic, involving the distance formula. So you want to find the distance between 2 points. Again, be careful of the directions because some of these problems might look the same but end up asking you different things. So this says find the distance. If you don't remember, the distance formula is this big thing over here. x1 minus x2 squared plus y1 minus y2 squared. So you take the x coordinates and subtract them, take the y coordinates and subtract them, square, add, root, in that order. So let's plug them in. Remember, the x coordinates are the first numbers in the points. So it'd be 2 minus 7 squared plus 6 minus 9 squared. And then you just kind of go down the list. 2 minus 7, well, that's going to be negative 5 squared plus negative 3 squared. Now remember, when you plug in the negatives, you have to plug it inside parentheses into the calculator, else it's going to give you a wrong answer, or just do it in your head. Negative 5 squared is 25. Negative 3 squared is 9. Add those, you get 34. And if you root that, you get 5.83. That's all it is to it. Again, you either know the formula or you don't. In this case, my x's would be negative 3 minus 4 squared plus 8 minus negative 4 squared. Now again, in truth, it really doesn't matter whether you put your x's first or your y's first. As long as you put your x's together and your y's together, you should be okay. So let's say here, this is negative 7 squared plus 12 squared. So if we do some arithmetic here, again, negative 7 squared is 49, not negative 49, plus 144. So that give me 193, which would give me 13.89. That is the distance there. So you plug in, check out an answer. Again, there is really no two ways about it. Again, make sure you remember your x's are your first, your y's are second in the points, and therefore you can pick the right numbers to put in the right spots. The next one is where you have to read the directions carefully, because these look like the same problem, but they're not. Because this one's not asking you to find the distance, it's asking you to find an equation. You want to know what equation represents the line that goes through these 2 points. This is the mx plus b stuff. It's actually down there at the bottom of the next question. So this is y equals mx plus b stuff. You need to find the m and you need to find the b. Well, the first thing you do, find your m. So your m formula goes as follows. Kind of like the distance, actually. y1 minus y2 over x1 minus x2. That's how you find your m. That's how you find your slope. So in this case, my y's are 5 minus 8, and my x's are 2 minus 3. 5 minus 8 is going to be negative 3. 2 minus 3 is going to be negative 1. And so I just get a positive 3 as my m. So that is the first piece of the puzzle. Now I need to figure out the b. So in order to figure out the b, I need a temporary y and x to use. So I'm going to pick this point right here, 2, 5, as my temporary x and y for 2 and 5. So I'm going to have my equation here, y equals mx plus b. My y temporarily is 5. My m, I found out before, is 3. My x temporarily is 2. And then I add the b. So now I just solve this equation. 3 times 2 is 6. And then subtract 6. And you get negative 1 equals b, which is not the final answer that I have. My final answer is the equation. So I'm going to plug it in. Y equals 3x minus 1, or plus negative 1 if you want, either way. So you have to find your m first using the slope formula, and then you plug in your reference point for y, m, and x, and then you can figure out your b from there. Same deal with the second one. So let's plug in our slope stuff. So remember, this is x, y, x, y. So 4 minus negative 9 is my y. Negative 3 minus negative 2 is my x. We look at it here, we get 13 over negative 1, which is negative 13. So that's my slope, that's my m. You can label it if you want to. The easiest reference point I can see would be the negative 3, 4, just because I'm picking it. So remember, I start with y equals mx plus b. Then I plug in my numbers. 4 is y, negative 13 is m, negative 3 is x, and then plus b. Again, I'm just plugging in this number for y, this number for x, and this number for m. All just what I found. Okay? And that is a negative 13 too. So when I do my arithmetic here, I get 4 is equal to 39 plus b. Subtract the 39. And I get negative 35 is equal to b, which is not my final answer, is just part of my final answer. My final answer is the equation y equals negative 13x minus 35. And that is all there is to it. So it's a longer problem than the other ones we just did. And it's a really step-by-step there. So you have to know what to do when. And it's very similar for all types of problems. Slope, pick a point, plug in the slope and the point, find your b value, write your equation. Number 8 is the exact same problem in word problem format. And ironically, it's actually easier when it's in word problem format because usually they tell you your slope rather than you have to figure it out. And same for the y-intercept. So remember, in this equation, y equals mx plus b. B is your initial value. So this is the starting amount or the one-time cost. Whereas m here is your slope or your repeated number. So m is the number on repeat. So in this case, we have a company that's charging a flat fee, so a one-time cost of $3.50, and then 15 cents every mile. It's a reoccurring cost. So $3.50 is my b because it happens once, and 15 cents, that's my m because it happens reoccurringly. So my equation y equals mx plus b is now going to be y equals 0.15x, because that's my slope. I should put 0.15, plus 350, because it's my b. Now I'm not done yet, because this is actually a two-part question. How much would it cost to go 10 miles? So here's the equation. That's the first part, write an equation. Now I want to figure out how much would it cost to go 10 miles. So I need to know what variable is my miles. Well, miles or distance is almost always an x number. So in this case, I want to know 0.15 for 10 miles. How much cost would that give me? So I'm going to plug in 10 for x, 10 miles, see what I get. Again, 10 times 0.15 is 1.5 plus 350 would give you a grand total of $5 even. So in this case, I plug in 10 for x because 10 represents the miles I have to drive. Or sorry, x represents the miles I have to drive, which is why it's not going to be 10. So again, usually you plug in numbers for x, although every now and then you might plug in one for y. The next one's very similar. In fact, it is the same, except different situation, different numbers. Here you have a movie fee. So it's $20 flat plus $4 per month. So the 20 here is my b value. The $4 per month is my m value. So my equation is going to look like this. So I plug in 4 for m and 20 for b, because 4 is my recurring value, 20 is my initial value. Now I want to use to figure out how much I'll pay after 1 year. So remember, x represents the months, because it says months right here. X represents the months. So 1 year would be 12 months. So it'd be y equals 4 times 12 plus 20. And then you do some math here. 4 times 12 is 48, plus 20 would give you a grand total of $68 for a 1 year membership. So again, when you have a word problem, figure out what number is repeating, what number is not, and that's your m and your b, and then plug those in to fill out your equation. The next two are kind of break problems, so they're a little bit more simpler. A little bit more simple, I should say. So all you're doing is solving for x. I'm going to get x by itself. So draw your line. First thing to do is get your x's together if they're on different sides of the equal sign. In this case, they are. I have a 3x on the left, a negative 2x on the right. I need to get them together. So I'm going to add this 2x because I want to move the entire thing, not just the 2, not just the x. I want to move them both, so I'm going to add. That goes away. I'm left with 14. Here I get 5x plus 4. Then I'm going to subtract 4 from both sides. I get 5x equals 10. Then I divide by 5. Again, every step I make is to try to get x by itself. So I move the 4 to get it away. I'm moving the 5 to get it away. So now I just have 2 left. So x would be 2. So when your x's are on different sides of the equal sign, you have to get them on the same side first before you start moving things around. Now number 11 has a little bit of a twisty twist to it. You have to do the same thing, but you have barriers now. You have those parentheses. So parentheses are not easy to deal with. You cannot move anything inside them until they're gone. And the way we get rid of them is by distribution. So we take this 2 on the outside and we multiply it to both things on the inside. That's called distribution again. So 2 times x is 2x. 2 times 1 is 2 equals 4x minus 10. And then we just run the gambit again. We want to try to get x's by themselves, so we have to put them together first. So I'm going to move this 2x over to the other x, because that way they'll be on the same side. So I get 2 is equal to 2x minus 10. Then I'm going to add 10 to both sides. And I get 12 is equal to 2x. Then I divide by 2. And I get x is equal to 6. Again, once you get your x's on the same side, it's just another equation. You usually add and then divide, or subtract and then divide in most cases. But your goal is to get your x's together first and then worry about moving stuff away. The next two are interior angle triangle problems, not Pythagorean triangle problems, but interior angles. And so I want to know what this missing angle is. And you have to know a fact here. All the angles in a triangle add to 180. So I want to know what is C. Well, I know that if I take angle A, which is 120, plus angle B, which is 34, plus angle C, which is some number I don't know, I should get 180. So I want to know, what do I have right now? Well, right now, if I take my two angles, I have 154 plus c, which is something, is equal to 180. Well, how do I get that missing x? Well, I subtract minus 154, minus 154, and I get x is equal to 26. That's how big that missing angle is, 26. So you have to know that they equal 180 and that everything added together is always going to equal 180 in a triangle. Same thing for number 13. 40 plus 70 plus this missing angle should still equal 180, even if it's a different triangle. Well, 40 plus 70, that's 110, plus x is equal to 180. And then you subtract 110 from both sides to get x by itself, and you get x is equal to 70. Same as its partner angle there. So for the triangle ones here, when you're trying to solve for an angle in a triangle, you have to know that they all add up to 180, and that's the trick you use to figure out the missing piece, because you figure out, what do I have? How much more do I need to get to 180? There's my answer. The next ones are also triangle problems, but they're Pythagorean problems. So Pythagorean problems revolve around this formula. A squared plus b squared equals c squared. And if you don't remember, c is always the side that's opposite the right angle. It's the longest side of the triangle. So I put my pen on the right angle mark, I draw an arrow, that's my c. Now we had two ways of solving this. If you're missing your c, you go through 3 steps. You take your two numbers that you have, you square them, just like in the formula up here, square them, add them, and then square root your answer. Because you want c, you don't want c squared like that. So you have to square root to get rid of that square that's going to be there. So 6 squared is 36, 8 squared is 64. That's 100. That gives you 10. Now you could plug and chug in the formula as well. You could plug in 6 for 8, or sorry, 6 for A and 8 for B, and solve it that way. But really it just revolves around 3 steps: square, add, and root. Now if the reverse is true, let's say you know which c is, it's 15. Here's what you do instead. You take your two numbers, bigger number always first. You square them, you subtract them, and then you root them. So it's the exact same steps with one minor change of subtracting rather than adding. So if we go through this here, 225 minus 100, which is 125, which is 11.18 when you square root it. So again, these revolve around 3 steps for both types: square, add or subtract, and then root. If you know your c, you subtract. If you don't know your c, you add. Now the last two are going to be the longest ones on the quiz because they just have the most steps. They're the solving systems. Now I do believe there is a misprint here where it says minus 3x. It should be minus 3y. So let me correct that here. That should be a minus 3y. So a system is when you have two equations that involve two unknowns at the same time. And you want to know what numbers would work in both of these equations. So I want to know what x and y pair could I use in both these equations to get a true answer. Or graphically, where did these two lines cross? That's what it is graphically. Now there's 2 types of these. 3 really, but 2 main types. The first type is the nice type, which is number 16 here. You don't have to do anything with it. Because the way you solve these is you're going to take your 2 equations and you're going to add them together. And what should happen when you add them together is one of the variables, in this case the y's, should just cancel out. Because positive 3y plus negative 3y just goes away. Makes a 0. Goes away. 2 plus 5 is 7x. 2 plus 26 is 28. Now what happened here is called elimination. I've eliminated the y variable. I've added them together, and the y variable is now gone. So what's left is just the x. And I can actually solve for this now. Because if 7x is 28, I can divide by 7, and I can get x is equal to 4. And now that I know that x is equal to 4, I can go back to my original problems, like let's say the top equation here. I can go back to the top equation and say, hey, I know that x is 4, so I can do this. 2 times 4 instead of x plus 3y is 2. And I can solve this equation now. 2 times 4 is 8, plus 3y is 2. Subtract 8 to get my y by itself. 3y is negative 6. Divide by 3, and you get y equals negative 2. So my answer is 4 comma negative 2. So the whole point about solving this equation right here is that you want to get it so that one of the variables will cancel when you add. That way you just have one variable left over to focus on. And once you get the answer to that one variable that's left over, you can plug it back in to find the answer to the second variable. In this case, the y. Now, you do not always have to get rid of your x or your y first. You can do either one you want, whatever is easiest. For example, number 17, we have negative 2x plus 5y equals negative 1, and then x plus 10y equals 7. Well, I need to get these to cancel when I add them together. Because right now when I add them together, negative 2x plus x is just negative x. And 5 plus 10y is just 15y. There's no 0 yet. Nothing cancels. So that's bad. I can't have that. I need to change one of them first. So I look here and say, okay, hey, this is a negative 2x. I could make this into a positive 2x if I simply multiplied everything by 2. If I multiplied everything by 2, then 1x would be negative 2x. 1x would be positive 2x, and when I go to add them, they'd make a 0, they'd cancel out, which is what I want, and then I'd be left to do what else I could do. So that's what I'm going to do, and sometimes you'll have to multiply one, sometimes you'll multiply both. Just depends on the type of problem you're given. In this case, it's just one. So I'm going to take 2 and multiply it to everything inside there. 2x plus 20y equals 14. Again, you have to multiply it to everything, not just the parts you want. Down here we have negative 2x plus 5y equals negative 1. Then I'm going to add these two things together. The x's will go away. 20y plus 5y is 25y. 14 plus negative 1 is 13. And so I'm going to divide by 25 to get y equals, rounding off here, 0.52. I believe I'm rounding off at least. So that is the first variable. That's y down. Now again, I need both a y and an x, so I can't just stop here. I need to go a little further and find out what my x number is by plugging y back in. Now y is a decimal, but I can still make it work. Actually, I don't think I am rounding off. I think 13 divided by 25 is exactly 0.52, which is good. So I can pick either equation I want to start with. I can pick either the bottom equation or the top equation to plug this 0.52 in. And for me, it'd be easier to do the bottom one just because 10's a nice multiplier and the x doesn't have anything with it. So I'm going to have x plus 10y equals 7. Now I know what 10y is. I know what y is. Y, I just found out right here, y is 0.52. So it's 0.52 times 10 plus x equals 7. Well, I have x plus 5.2 equals 7. Then I subtract 5.2 from both sides, and I get x is equal to 1.8. And so my answer is the point 1.8 comma 0.52, because again, technically speaking, you are finding the point where these two things cross, where these two lines cross, and they cross at that point there. So that is the breakdown of the guide for the pre-algebra final. Again, there's a lot of formulas at the beginning, so make sure you memorize your formula: sphere, cylinder, cone, distance, all that stuff there. Make sure you know the mx plus b stuff, because that's going to be a large part of it as well. And if you know those two things, you're pretty well set. You should be a-okay for the test to come. Hope you enjoyed the video. Good luck on the final. Have a good day.